We're continuing on here in chapter 10. We're doing this secant and tangent segments. Okay, first one we're going to talk about is segments of chords theorem. If two chords, so if we have two chords intersect in the interior of a circle, then the products, meaning multiplication, of the chord's smaller segment lengths are equal. So what does that mean? Well, here it is. So if I look, I have a smaller segment AE multiplied to a smaller segment EB. That is going to equal the smaller segments of the other chord. So DE multiplied to EC. Okay? Now, be prepared because on here, there is a chance you're going to get more quadratics going through with this part. So here we go. Segments of chords. Here we go. So let's try a couple. So the first one I'm going to do is I'm going to say, okay, I have 2 and x plus 1. So those are going to get multiplied. And that will equal the other chord segments, 3 and 4, multiplied together. So now we do the math here. We're going to distribute the 2. So that's going to give me 2x plus 2 equals 12. We would minus the 2. So that's going to get us 10. Divide by the 2, x is 5. We take that. We can double check it just to make sure. Plug 5 in. 5 plus 1 is 6. 6 times 2 is 12, and it definitely works. All right, let's try the second one. So on this second one, again, we're going to start off pieces of the first chord. So I've got x times the quantity x plus 4, and that is equal to the second chord, x plus 1 times x plus 2. Okay, so now we take and we're going to distribute. So that's going to give me x squared plus 4x. And then on the other side, we're going to distribute x squared plus 2x plus 1x plus 2. Combine our like terms, so x squared plus 4x equals x squared. We have like terms here, so that would be 3x plus 2. Then I'm going to start moving. So my first thing I'm going to move is I'm going to minus the the x squared from both sides. Luckily, that cancels. That takes it out of being a quadratic then at that moment. So now I'm going to minus the 3x. That would give me a 1x equals 2. Now, if that didn't cancel out our x squareds, then what we would have to do is either quadratic formula or solve by factoring or one of those methods in order to solve that. So let's try this third one here. Same process, same setup. So we're going to start off, I've got an x and an x plus 4. And then on the other side, I have 5 times 12. So that's going to get us. Now at that then, we start to solve. So I'm going to distribute first. So x squared plus 4x. And that equals 60. Now, since it is a quadratic and we have a b, by b I mean that value right there, then what we do to solve a quadratic is we move everything to one side and set it equal to 0. Then at this point, we're going to try to factor. If it can't factor, then we're going to go to the quadratic formula. So when I look at the factoring, I look here and I say, okay, this sign tells me that my signs are going to be different. And then I look back, since it's a negative, it tells me they're going to be different. I look back and this tells me my biggest number that I use is going to be the plus. So I'm going to come down here, I'm going to put 1 plus, 1 minus. And then what I look for are the factors of 60. So I'm going to go 1 and 60, 2 and 30, 3 and 20, 4 and 15, 5 and 12, 6 and 10. So when we look at that, we're looking, since my signs are different, we're looking for it to subtract to give me 4, which would be 10 and 6. The bigger number is going to be the plus. The smaller number is going to be the minus. Then I take each of those, set them equal to 0. And now I solve, so I minus the 10. So x equals negative 10. I add the 6, and I get x equals 6. Then I look and see, can both of those work? Well, if I plug 6 into the original, 6 plus 4 is 10, times 6 is 60, which that one works perfect. That one's all good to go. When I plug negative 10 in, it works in the equation, but over here, if I plugged it in, it would be a negative 10 for that measurement. And we cannot have a negative measurement, so that gets excluded from our solution. So our answer would just be 6 there. So that's how we handle chords intersecting inside of the circle. Next one, we're going to do segments of secants. So we start off, first thing, if two secants intersect and have the same endpoint outside of the circle, then the products, multiplication of the external secant segment and the full secant segment are equal. All right, so what does that mean? Well, if we look at this, we have the external EA multiplied to the full, which would be EB. That is going to equal the external EC times the full ED. And that would be our process there. Okay, so external times the full. So here we go. Let's try a couple of these. So the first thing I'm going to do is I'm going to find the full. So if I go 9 plus 11, that's going to tell me that's 20. Down here, I'm going to go 10 plus x. So that full would be x plus 10 or 10 plus x. It doesn't matter. So now I'm going to go to set it up. So I'm going to start off. Let's just start here. I have the external 10 and the full. So that's going to give me 10 times x plus 10. And that is equal to, and now we're going to come back. I'm going to take the external times the full. And that's going to give me 9 times 20. So at this now, we're going to start to solve. We're going to distribute. So that will give me 10x plus 100 equals 180. I'm going to minus the 100. So 10x equals 80. Divide by the 10, x equals 8. If I plug that back in, 8 plus 10 is 18 times 10 is 180. And it makes all the sides positive measurement links, so 8 works just fine. Okay, let's try the second one over here. So the first thing I'm going to do is find my links. So I've got here, I've got this measurement. The full length would be x plus 3. The second one here, the full measurement would be 10. So now we go in. I'm going to have x times x plus 3. And on the other side, external would be 4 times the total. So I would have 4 times 10. So now we can distribute that, and that would give us x squared plus 3x equals 40. I have a quadratic, I have a b value, so I move everything over, set it equal to 0. Then at this point, we would go to factor. So we would look at that and we would say x and x. We take a look at this symbol, that tells me the signs are going to be different. So then I look back, that tells me the bigger one is going to be the plus. So factors of 40, we have 1 and 40, 2 and 20, 4 and 10, 5 and 8. My signs are different, so I want them to subtract to equal 3. So that's going to be 8 and 5. So then I set that equal to 0, so x plus 8 equals 0, which is going to give me x equals -8, and x minus 5 equals 0, which is going to give me x equals 5. I look, does that work? 5 plus 3 is 8. 8 times 5 is 40. So the 5 works perfect. The -8 works in the equation, but when I plug it back in up here, I get a measurement that would be a negative length, which throws it out. So x equals 5. Now, for those wondering, I do want to show you, I'm going to show the exact same problem using the quadratic formula, just so you see it just as a quick review. Okay, so when we do the quadratic, what we do, remember, it's based off of the fact of ax squared plus bx plus c equals 0. So we look at those numbers. The a is attached to the x squared, the b is attached to the x, and the c is attached to by itself. So when we look at this, here's the one I'm focusing in on, my standard form of a quadratic. So when I look at this problem, then I know that a would be 1, b would be 3, c would be -40. So then if I take that and plug that in, so it looks like this. Remember, it goes x equals -b plus or minus the square root, b squared minus 4ac all over 2a. So when we plug that in, we get negative of 3 plus or minus the square root, 3 squared minus 4 times 1 times -40 all over 2 times 1. Now we're going to do some simplifying. So 3 squared is 9. -4 times -40 is positive 160. So that whole thing turns into -3 plus or minus the square root of 169 all over 2. 169 is a perfect square. It's 13. So here are my two answers then. I have x equals -3 plus 13 divided by 2. And I have x equals -3 minus 13 divided by 2. And then we just simply work those out. So -3 plus 13 is 10. 10 divided by 2 is 5. And we said that one works. And then the second one here, -3 minus 13 is -16. -16 divided by 2 is a -8. That one did not work. So that's how you would do that exact same problem using the quadratic formula. So if your factoring gets too challenging, if you can't find it quickly, just do the quadratic formula. You will always get the same answers. And the quadratic formula works for everything. So, okay. All right, let's take a look at this last rule. The last one is, how do we handle a secant intersecting with a tangent? So I'm going to start off. It says, if a secant segment and a tangent segment intersect, then the product, multiplication, of the external secant segment and the full secant segment is equal to the tangent segment squared. Okay, so what does that mean? Well, I have a secant and a tangent. So my exterior secant segment, EC, multiplied to the full length, ED, is equal to the tangent squared, EA squared. Okay, so EC times ED equals EA squared. All right, so here we go. So I'm going to start off. First thing I want to do is I want to find the full length. So the full length of the secant here would be x plus 5. So now if I take the external to the full length, I would get I'm going to get 5 times x plus 5. And that will equal then the tangent squared which would be 7 squared. And then at that point, we're going to distribute. So 5 times x, 5x, 5 times 5, 25, and that equals 49. I minus the 25, and that gives us 24. Divide it, so x equals 24 fifths. Or we can write it also as a decimal, and that would be 4.8. Okay, let's try the second side here. So on the second one, I need to find the full length of my secant, which this case would be 4. So I'm going to take my external times that. That's going to be my first statement, so 4 times 1. And that is equal to the tangent squared, so x squared. So now we go to solve this, and we've got 4 equals x squared. Well, if you notice, there's no b in that problem, no bx. So I can solve this a different way. It's called the square root method. We simply take the square root of both sides, and we get x equals plus or minus 2. And then I look back and say, okay, does a positive 2 work? And it does. And then I double check, does the negative 1 work? And the negative 1 would not, because it would make a negative measurement there with the x. So we exclude the negative, and so my answer would be x equals 2. All right, let's try this last one then. So on this last one, we're going to start off, I'm going to find my full secant, which would be x plus 7. So now I'm going to take and go my external times my full, so x times x plus 7, and that is equal to the tangent squared. So now we're going to distribute that, and we're going to start to solve. So x squared plus 7x equals 144. I'm going to minus. So x squared plus 7x minus 144 equals 0. So now we could try to factor it. Let's see if we know all our factors. A 144, quick enough and easy enough to make it worth our while. This one tells me the signs are going to be different. This one tells me the signs are going to be, the plus is going to go to the biggest number. So now I'm just going to come over here, factors of 144. So here we go. We got 1 and 144, 2 and 72, 3 and 48, 4 and 36. 5 doesn't go. We have 6 and 24. 7 doesn't go. 8 and let's see, that would be 18. Still haven't found it. 9 goes, and 9 would be 16, and that is 7 units away. So that would be my combination. So 16 and 9. Set those equal to 0. And solve. So this one's going to give me x equals negative 16. This one's going to get me x equals 9. 9 works beautifully in it. Negative 16 won't, because it would give us a negative measurement. So x equals 9. Now, I know we did quadratic stuff quite a bit on this. Be prepared, because that shows up quite a bit in this. But if you have further questions about either the quadratic formula or solving by factoring or solving by the square root method, feel free to stop by. I'd be more than happy to go over it a little more detailed with you to hopefully help you get it a little more down, because it is an essential way of solving as we move forward through the math cycles with Algebra 2, Pre-Calc, so on and so forth. So feel free to come in if you need some additional help on solving quadratics.